Assalamualaikum and hi everyone. Here is the solution process for chapter 6, circular motion. Example 6.1. The objective is to convert units between degrees, radian, and revolution or rotation. Okay, an object travels around the circumference of a circle of radius 3 meter at a rate of 15 revolutions per minute. So the information that we have from the question, the first one is radius r, and then the rate of 15 revolutions per minute, which is omega. So the question asks A to calculate its angular speed in radian per second. So angular speed is omega. Alright, to answer this question, we simply need to convert 15 revolutions per minute to radian per second. As you can see, there are two units that we need to convert. The first one is revolution to radian, and then minute to second, which means we need to multiply with two conversion factor here. Okay, two conversion factor. Okay, notice that the unit on the top is revolution. Okay, we need to put the same unit at the bottom here. So revolution. So we always want to set it up in such a way that this unit will cancel. Okay, we know that one revolution is equal to 2 pi radian, and then same goes to this unit, minute. Okay, we need to put the same unit at the top here so we can cancel. Okay, so 1 minute is equal to 60 seconds. So finally we will have 50 times 2 pi radian divided by 60 seconds. So the answer is pi over 2 radian per second. Okay, next question B. Calculate its linear speed around the circular path. So linear speed, the symbol is V. As we know, the relationship between the linear speed and the angular speed is V is equal to R omega. So we simply substitute the value of R and omega here. So R is 3 meter and omega is pi over 2 radian per second, and finally we will get the answer is V is equal to 4.71 meter per second. Okay, example 6.2. A motorbike moving at a constant speed 20 meter per second in a circular track of radius 25 meter. So the information, first one is speed V 20 meter per second, and second one, the radius R is 25 meter. So the question asks to calculate the centripetal acceleration of the motorbike. So centripetal acceleration is AC. So AC is equal to V squared divided by R. So we simply substitute the value of V and R. So V is 20. So 20 squared divided by the radius 25. So the answer will be AC is equal to 16 meter per second square, and the direction is always towards the center of the circular track. Okay, next B. The time taken for motorbike to complete one revolution. So time taken for one revolution is period capital T. Okay, previously we learned that speed V is equal to total distance divided by the time taken. So for one complete revolution, the total distance is simply the circumference of the circle, which is 2 pi r. And the total time for one complete revolution is the period capital T. So we have the equation V is equal to 2 pi r over T. So we will rearrange the equation, let T be the subject of the equation. So T is equal to 2 pi r divided by V. So 2 pi r, 2 pi times the radius 25 divided by V. V is 20. And finally, we will get the answer. T is equal to 7.85 seconds. We also can use directly the equation of AC is equal to 4 pi square r over T square. So we will get the same answer. Okay, next example 6.3. The objective is to solve problem related to centripetal force for horizontal circular motion. Okay, a ball of mass 150 grams is attached to one end of a string 1.1 meter long. The ball makes 2 revolutions per second in a horizontal circle. Okay, the information that we have here, first one is the mass, and then the length of the string is equal to the radius of the circle, so r is 1.1 meter. And next one is the frequency f, which is 2 per second. Right, the question asks to sketch a free body diagram for the ball. Okay, sketching the free body diagram. So the first step, sketch and label all the forces acting on the ball. The first one is the weight of the ball, which is always directed downwards to center of the earth. We label as mg. The next one is the tension provided by the string, which is always directed away from the object, and we label as capital T. And we know that the centripetal acceleration is always directed towards center of the circle. Next, the second step, then we sketch a free body diagram of the ball. So we draw the x and y axis, and then we transfer the blue arrow up here. So the first one, the mg, downwards. Next one, tension to the right. So that is the free body diagram of the ball. Okay, next question B. Determine the centripetal acceleration of the ball AC, and then the magnitude of the tension in the string T. So first we write down the information we got from the question. The first one is M, mass is 0.15 kilogram. And then next, the radius is 1.1 meter. And next one is the frequency, which is 2 Hertz. Okay, so for question 1, AC is equal to V square over R. So the first step, we need to calculate the linear speed first. So V is equal to R omega. So omega is 2 pi f, so we have V is equal to 2 pi f r. So 2 pi, the value of f is 2 and r is 1.1 So we will get our linear speed v is equal to 13.8 meter per second. So now we can calculate the centripetal acceleration. AC is equal to, we substitute the value of v, which is 13.8 square divided by r, which is 1.1, and get the answer of AC, which is 173 meter per second square, and the direction is towards center of the circle. Okay, next for question 2, the magnitude of tension in the string. Okay, the net force that causing the uniform circular motion is we call as centripetal force, which means is the centripetal force enable the ball to move in circle, which is it's provided by the tension in the string. Hence, the total force in component X is equal to the centripetal force Fc. So the only force that we have in X component is the tension. So T is equal to centripetal force AC. So T is equal to, substitute the value of M, which is 0.15 times the centripetal acceleration we calculated in question 1, so 173. So we got the answer of tension is 26 Newton. Example 6.4. The objective is to solve problem related to centripetal force for vertical circular motion. A small remote control car with mass 1.2 kg move at constant speed of v is equal to 15 meter per second in vertical circle track of radius 3 meter as shown in figure 6.1. The question asks to determine the magnitude of the reaction force exerted on the car by the track at point A and point B. Given the value of acceleration due to gravity, g is equal to 9.81 meter per second square. Alright, the information we have are, the first one is mass m 1.2 kilogram, and then speed v 15 meter per second, and then r radius 3 meter. Okay, write down all the information we got from the question. Right, in order to solve this kind of problem, the first step is we need to sketch the free body diagram. Okay, now refer the diagram of the car at point A at the bottom of the track. So the forces acted on the car are, the first one is the reaction force. Okay, the reaction force is always directed perpendicular to the surface. We label as NA. And the second force is the weight of the car, which always directed downwards to the center of the earth, and we label as mg. And we know that the acceleration, the centripetal acceleration, is always directed to the center of the circle. Now we can solve the problem. Okay, the summation force component y is equal to Fc. So the forces that we have at component y is NA and mg. Since NA is same direction with the centripetal acceleration, so NA is positive and mg is negative since it's opposite direction with AC. So now we will write the total force, which is NA plus negative mg is equal to mv square over r. So rearrange the equation, we add both sides with mg. So we have Na is equal to mv square over r plus mg. So we substitute all the value. So the mass of the car is 1.2 times the velocity 15 meters per second square, and the radius is 3 plus 1.5 times 9.81. So the reaction force at point A will be 101.8 Newton. Okay, next is question B. The reaction force at point B. Now we refer to the diagram of the car at the top of the track. Okay, so first we sketch the free body diagram. The forces acted on the car are, the first one is the reaction force, which is always directed perpendicular to the surface and we label as NB. And the second force is the weight of the car, which is always directed downwards to the center of the earth and we label as mg. And we know the centripetal acceleration is always directed to the center of the circle. And now we can solve the problem. So the summation of force at component y is equal to Fc. So the forces that we have is NB and mg. Since both forces are same direction with the acceleration, so the forces are positive. So we're going to write NB plus mg is equal to mv square over r. Okay, thus NB is equal to mv square over r minus mg. So now we will substitute all the value of m, v, r, and g. So the mass is 1.2 times the velocity is 15 square divided by the radius r is 3 minus 1.2 times 9.81. So the answer of the reaction force at point B is 78.2 Newton. Example 6.5. Okay, a rider on a Ferris wheel moves in the vertical circle of radius r is equal to 8 meters. So the radius is 8 meters at constant speed v as shown in figure 6.2. If the time taken to make one rotation is 10 seconds, so the time taken for one rotation, this is the period, and the mass of the rider is 60 kilograms. So this is the mass. So the question asks to calculate the normal force exerted on the rider, A at the top of the circle, B at the bottom of the circle. Given the value of G is 9.81 meters per second square. Okay, in order to determine the reaction force or normal force for question A and B, we need to calculate the linear speed of rider first. So we're going to use the formula V is equal to 2 pi r over t. So 2 pi r times the radius 8 meters divided by 10 seconds. So we get the linear speed of the rider is 5 5.03 meter per second. Okay, now we can answer question A to calculate the normal force exerted on the rider at the top of the circle. So the first step, we need to sketch the free body diagram. Okay, the first force acted on the rider is the normal force directed upwards. It is always perpendicular to the surface. The second force is the weight of the rider directed downwards to the center of the earth. And the centripetal acceleration is directed to the center of the circle. Since the weight is same in direction to the acceleration, so the force is positive. Meanwhile, the normal force is negative because it is opposite in direction to the acceleration. Okay, now we can write the net force in component Y. So the total force in component Y is equal to the centripetal force Fc. So the forces that we have, mg plus negative n top is equal to mv squared over r. So rearrange the equation. So n top is equal to mg minus mv squared over r. So the mass of the rider is 60 times G9.81 minus 60 times the speed, which is 5.03 square divided by the radius 8 meter. And we get the answer is 398.8 Newton. Okay, next for question B, we're going to calculate the normal force acted on the rider at the bottom of the Ferris wheel. Okay, sketch the free body diagram. So the first force is the normal force directed upwards, perpendicular to the surface. And the second one is the weight of the rider directed downwards to the center of the earth. And the centripetal acceleration is directed to the center of the circle. The normal force is positive, since it's same direction with the AC, and the weight is negative. So now we can write the total force. So the net force in component Y is equal to the centripetal force Fc. So the forces that we have, and bottom plus negative mg is equal to mv squared over r. So rearrange the equation. So n bottom is equal to mv squared over r plus mg. So we substitute the value. So the mass of the rider is 60 kilogram times the velocity is 5.03 square divided by the radius, which is 8 meter, plus 60 times 9.81, and we get the answer for the normal force acted on the rider at the bottom of the Ferris wheel is 778.4 Newton. Alright, next, example 6.6. The objective is to solve problem related to centripetal force for conical pendulum. Okay, figure 6.3 shows a conical pendulum with a bob of mass 80 kg on a 10 meter long string making an angle of 5 degrees to the vertical. Okay, the information from the question are, the first one is the mass, and then the length of the string, and the last one is theta. Alright, so the first question asks to sketch a free body diagram of the bob, and next question B, to determine the tension in the string, so the one is F, and then B2, the speed and period of the bob, so speed is V, and then period of the bob is T, and last one is radial acceleration, which is AR. Alright, so question A, sketch a free body diagram of the bob. Okay, the first step is we sketch and label all the forces acting on the bob. Okay, so the first force is the tension. It's directed along the string, and the second one is the weight of the bob, directed downwards to the center of the earth, and the centripetal acceleration is directed to the center of the circle. Okay, next, the second step, we can sketch a free body diagram of the bob. So we draw the x and y axis, whereas the origin is the bob, the center of mass of the bob. So we draw the tension and then the weight of the bob. Lastly, the centripetal acceleration to the left. Okay, now look at the free body diagram. You can see that the force is two-dimensional force, so we need to resolve the force. So we have F cos theta for the y component and F sin theta for the x component. So referring to the vertical component of the body diagram, so we have two forces, F cos theta and mg. Since the object is not moving in vertical component, so we can write summation of force in y component is equal to 0. Thus, we have F cos theta is equal to mg. So since we going to determine the F, so let the F be the subject of the equation. So F is equal to mg divided by cos theta. So we substitute all the values. So the mass is 80 kg, gravity 9.81 divided by cos 5. So make sure the calculator is in degree mode. So we will have the answer 788 Newton. Okay, since the centripetal force is contributed by the horizontal component of the tension, so we can write summation of force in component x is equal to the centripetal force. So the only force that we have in component x is F sin theta. So F sin theta is equal to mv squared over r. Okay, so we need to determine the expression of R first, so then we can solve for the tension. Okay, now we are going to determine the expression of R in terms of L. Okay, please refer to the diagram. So that one is the length of the string L, and that is the radius of the circle. Okay, using the Pythagoras theorem, this is the opposite side, this is the adjacent, and this one is the hypotenuse. So we will use the sign which is so. So we will get sine theta is equal to R over L. So we will rearrange the equation, making the r as the subject of the equation. So we will have r is equal to L sine theta. So we will substitute this expression into this equation. So we will have F sine theta is equal to mv square over L sine theta. And we will rearrange the equation, let the v as the subject of the equation. So we will have v is equal to FL sine square theta divided by m square root. So we will substitute all the values there. So the F is 788, the length is 10 meter, sine square theta is 5, divided by the mass of the bulb, which is 80 kilogram. So the velocity we will have 0.87 meter per second. Okay, next question B2, the period of the bulb. So the equation of period, T is equal to 2 pi r over V. So we will substitute the expression of r here in terms of L. So T is equal to 2 pi L sine theta divided by V. So T is equal to 2 pi, L is 10 meter, sine 5 divided by V, which is 0.87. And finally, we will get the answer, which is 6.3 seconds. Okay, last question, B3, to determine the radial acceleration. Okay, from the definition of the radial acceleration, which is AR is equal to V square over R. So we will substitute the expression of R here in terms of L. So V square over L sine theta. So substitute all the value. So V is 0.87 square divided by the length, which is 10 sine 5, and finally we will get the answer of the radial acceleration, which is 0.87 meter per second square, and the direction is toward the center of the horizontal circle. Okay, next example 6.7. Okay, the objective is to solve problem related to centripetal force for motion rounds a curve on flat track. Okay, so the question: a car of mass 2000 kg rounds a circular turns of radius 20 meter. Okay, the road is flat and the coefficient of friction between tires and the road is 0.7. So the information that we have, first one is the mass, and then r radius, and last one the coefficient of friction mu k, which is 0.7. Okay, so the question asks A to sketch a free body diagram of the car, and then B to determine the maximum car speed without skidding, which is Vmax. Alright, question A, to sketch free body diagram of the car. Okay, here's the car, then one center of the circle. So the centripetal acceleration is directed toward the center of the circle. So the forces acted on the car, the first one is the weight of the car, which is directed downwards to the center of the earth. The second force is the reaction force, which is perpendicular to the surface. And the last one is the friction force to the right, keeping the car from slipping. Okay, next for question B, we are going to calculate the maximum car speed without skidding. Okay, from the diagram in A, okay, we can say that the car is not moving in the Y component. Okay, so we can write as summation of force in Y component is equal to 0. Thus, N is equal to mg. Meanwhile, in X component, the friction force is the only horizontal force acting on the car, okay, which means the centripetal force is provided by the frictional force between the wheel and the road. Okay, so we can write as summation of force in X component is equal to the centripetal force. So the only force that we have in X component is the friction force. So friction force is equal to mv square over r, and the formula of frictional force F is equal to mu n. So we will substitute the expression of n. So F is equal to mu mg. Okay, so mu mg is equal to mv square over r. So we divide both sides with m, so we cancel m. And finally, we will have the expression of V is equal to square root mu Rg. So we will substitute all the value. So mu is 0.7, R is 20, and G is 9.81. And finally, we will get the answer of the maximum car speed without skidding is 11.7 meter per second. That's it. Okay, so that's all for chapter 6. Thank you for watching.